All right. This is going to be Objective 21. We are going to recognize arithmetic sequences and geometric sequences. Any questions about what we are doing today? So there is going to be a little bit of vocab today. This is just an introductory lesson. I think you're going to find it to be very simple. So here we go. Let's get to it. All right. So a little bit of vocab. You just told me that a sequence was a set of numbers in a particular order or pattern. Okay, and you are correct in that. A sequence is a set of numbers that goes in a particular order or pattern. When I refer to a term, I'm talking about each number in the sequence, or a specific number in the sequence. A finite sequence is a sequence containing a limited number of terms, which means it has a starting point and a specific ending point. I'm going from 1 to 10, and that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's it. And those are the only numbers in the sequence. An infinite sequence is a sequence that continues without end to infinity. Okay, it says finite. Yes. Today we're going to do an introductory lesson on the difference between arithmetic and geometric sequences. Once we understand the basics today, tomorrow we're going to take a look, we're going to dive more into arithmetic sequences and series, and then we're going to spend a day on geometric sequences and series, and then we're going to spend a day on infinite series, okay, that go forever. All right, everybody got these? I promise before you make a sound, there's 2 more definitions you got to know. So here's one of them. Generally when I pop up everybody goes, oh, more writing. Okay, but let's talk about, we're first going to talk about arithmetic sequences. Arithmetic sequence is a sequence where each term is determined by adding the constant value to the previous term. That constant value, what you're adding to every term, the pattern, what you're adding, is called a common difference. Okay? So the key word here is adding. Okay, and it has a common difference. Will it always be able to determine, like, will you always know just right off the bat what you're adding to one number to get to another number? No, sometimes it's harder, like with more difficult number or fractions or decimals. So if you don't know what you're adding to this number to get to the next number, what could you do to figure out what you're adding? You could do the opposite. You could subtract. Do you see where they're getting the word common difference? Does that make sense? If you can't add, you can do the opposite and you can subtract the second number from the first number, and that would be your common difference. Everybody okay? Okay. So I just want to know, is this sequence arithmetic? Okay. So if it's arithmetic, then we know that it will have what? It's going to have a common difference. It's going to be adding the same number every single time. So can you tell me, what am I adding to 5 to get to negative 6? Negative 11. Anybody going to admit to me you didn't know that off the top of your head? Okay, so, and that's great, because there's probably several of us who had to like scratch our head just a little bit to think about that. So let me just remind you, if you don't know what you're adding 5 to get to negative 6, you can do the opposite. You can take negative 6 and do what with it? Subtract 5. So what is negative 6 minus 5? Negative 11. Okay, same thing here. What are you adding to negative 6 to get to negative 17? Negative 11. But if you didn't know that, you could take negative 17 and subtract negative 6. And when you subtract negative 6, that means you're actually adding 6, right? And so I agree. So what am I adding there? I'm adding negative 11. So that makes our common difference. My D is equal to negative 11. And so we would say, yes, this is arithmetic. Yes, this is arithmetic. Any questions on that? So I want you to determine, is the sequence arithmetic? Again, if you don't know what you're adding to the first one to get to the second one, you can subtract the second one from the first one to get your common difference. Okay, is it arithmetic? You gotta be careful. What am I adding here? So plus 16, what am I adding here? 16, what am I adding here? Uh-oh, it does not have, I'm not adding the same thing every single time, so this would be no. There is no common difference, therefore it is not arithmetic. Any questions? Is it arithmetic? No. What are we adding here? Plus 5 and then, uh-oh, so you can stop right there. It's no. Okay. One more. And then we will move on. Is it arithmetic? Yes. What's our common D? 9. D would be equal to 9. So, and again, if you don't know what plus negative 6 is 3, let me just reiterate, and I'm going to reiterate it several times because it's not always going to be this obvious, okay? So you can take 3 and subtract negative 6, which means you're actually adding 6, and you get 9. So that's plus 9, that's plus 9, that's plus 9, so this would be yes. Okay? All right. So what we're going to do now is I want you to find the next 4 terms in the sequence. Find the next 4 terms in the sequence. What's my common difference? Whoops. D is equal to -4, and so the next 4 terms would be 6, 2, -2, -6. Dot, dot, dot. Any questions? How many got it? Yay. This is amazing, right? It feels so good. Nice little break for her. It will get slightly more difficult tomorrow, but it's formulas, and they're on your formula sheet, and you plug in what the concept is tomorrow. You plug in what you know, you solve for what you don't know, and you answer the question. Does that make sense? You plug in for what you know, you solve for what you don't know, and then you answer the question. So it'll still be very simple because it's just formulas. All right, what's our common difference? -7. So what would the next 4 terms be? -3, -10, -17, and -24. Okay? Everybody good? All right. All right, let's go to, everybody feel good with arithmetic sequences? Those are sequences, patterns where you add to get the next term by finding the common difference. Geometric sequences, it's going to be the same thing, except instead of adding, we are now going to be multiplying to get to the next term. And that number is called a common ratio. Anybody know why it's called a ratio? Anybody know what a ratio is? It's like a fraction. Well, if we're multiplying, why would we be finding a fraction? Because if you can't multiply to get the next number, what can you do? You can divide the second number by the first number, and that makes a ratio. That makes a fraction when you divide it. Does that make sense to everybody? It makes a fraction when you divide it. And so that's why it's called a common ratio. It's good. That's good practice for college.
You know what the best thing is? Do after school.
Here we go. So my question to you is the sequence geometric? Is the sequence geometric? If it is geometric, then that means it's going to have a common ratio, which means we will be multiplying by the same thing every time. This is R equals. Very good. Yes. And you'll need to know, like when we have the formulas tomorrow, if the formula has a D in it, then they're talking about the common difference. If the formula has an R in it, then it's talking about the common ratio. Okay, so I agree. Is this geometric? Yes. What are we multiplying every time? We're multiplying by -3. Okay, every time. What if, now this one was fairly simple. What if we didn't know what times -2 was 6? You could take 6 and divide it. See, you got your ratio here. 6 divided by -2, and that is -3. So I do agree R is -3, and this would be a yes. All right, let's take one more before lunch, and then we will take a break till after lunch. Is this geometric? No. Let me ask you this. Let's go through this. What am I timesing by 8 to get to 16? That one's easy. What am I timesing by 16 to get to 24? How do you get that? You take 24 and you divide it by 16. That will tell you that you're timesing by 1.5. Does everybody understand that? What am I timesing by 24 to get to 32? 1.3 repeating. And you got that because you took 32 and divided it by 24. Do you understand? And so this would be a no. This is not geometric. Okay? All right, so we'll take a break there till lunch. Here we go. All right, so I want you to find the next 3 terms in the geometric series. So before we left for lunch, we were talking about arithmetic sequences that have common differences. And then we just went into geometric sequences that have common ratios. No, I want to know what you're multiplying by. Now, to figure that out, yeah, you can divide this. It can be a fraction. If it's getting smaller, it means you're going to be multiplying by a fraction. Because if you multiply this by something bigger than 1, then it's going to make it bigger. But if it's getting smaller, then you're going to be multiplying by a fraction. Okay, so what is our common ratio? 1/4. Any questions on it being 1/4? Again, if you don't know what times 32 is 8, you can take 8 and divide it by 32. You get 0.25, but then you change it to a fraction, and that would be times a fourth. So what would the next 3 terms be? 1/2, 1/8, 1/32, 1/32. Dot, dot, dot. How many were able to get that? Good. Any questions? Any question about being a fraction? Okay. Find the next 3 terms in the geometric sequence. What's the common ratio, Nate? 3. Okay. And what do you think the next 3 terms are? 1701. How many got that? All right. Any questions? Very good, Nate. All right. Wrapping it up. Last couple examples. My question to you is this. Is this sequence arithmetic? Is it geometric? Or is it neither? No, I do not believe it could be both. Somebody asked that in second block and had to think about it for a minute. And I used 2 for an example. Like, could you times by 2 and add 2? Well, okay, that would work to get to 4, right? But then if you take 4 and times it by 2, you get 8. But if you take 4 and add 2, you only get 6. Like, it's not going to work as it continues down the sequence. My question is it arithmetic, is it geometric, or neither? What are you testing for? You're testing to see if it's arithmetic, then it will have a common difference. If it's geometric, then it will have a common ratio, and if it's not either one of them, then it's neither. Okay, so you're testing to see, does it have a common difference, or does it have a common ratio? So what do we think about this one? Arithmetic, geometric, or neither?
Geometric.
Geometric. Very good. What's the common ratio? 3 halves, or you could say 1.5. That would be fine. So R is equal to 3 halves or 1.5, and so we would say this is geometric. Thumbs up if you got geometric. Ryan, how you doing? Thumbs up? Okay. All right, 2 more examples left, and we're done. Is it arithmetic, geometric, or neither? Example 13 is our last one. Is this arithmetic? No, we're not adding the same thing every time. This is adding 3, and then that's adding 5, so that doesn't work. Okay, is it geometric? No, so this would be considered neither. All right, last one. And everybody goes, whoa, this is not difficult. Can you in your calculators put in 2 and subtract 5/3 to see if it has a common difference? Yes. Jody, arithmetic, geometric, or neither? The first one, arithmetic. Very good. What's the common difference? 1/3. Okay, any questions about that? So we would say this is arithmetic. How many feel great? How many wish I was taking a grade on this?